In the previous video, we actually used Wilson's theorem. P minus 1 factorial is congruent to -1 modulo P, and where P is a prime number. But if we don't use, if we cannot use Wilson's theorem, we will have to prove it. So for example, if P is 11, then we get P minus 1 is 10. So which the left side will be 10 factorial. So what we're going to do is to expand 10 factorial. That's like 10 times 9 times 8, 7, 6, 5, 4, 3, 2 times 1. And we're going to pair. We got 10 integers. We're going to pair them up. Which numbers do we pair them up? We're going to try to pick the two numbers such that the product is congruent to 1 modular 11. So modular 11, but we want to pick, for example, 10. 10 times which of these numbers will be congruent to 1 modular 11. So if I pick 10 times 9, that will give me 90. And 90 divided by 11. 90 divided by 11, we get remainder 2, which is not 1. So that doesn't work. And then I try 10 and 8. So I'm gonna try 10 times 8. That will give me 80. And 80 divided by 11, and that will give me a remainder 3. That doesn't work either. So I'm going to try 10 times 7. 70 divided by 11, the remainder is 4. Doesn't work. So keep trying and do 10 times 6. That's 66. Remainder is 5. And 10 times 5, 50. The remainder is 6. And keep trying. And we keep trying this, and we find out actually 10 times any of them will not give us a remainder 1. But if we do 10 times 1, 10 divided by 11, the remainder will still be 11. But if I take, subtract 11 from 10, that will give me a -1. So actually, 10 times 1, if we pair these two up, we will still get 10, which is congruent to -1 modulo 11 by the definition. Definition of congruence relation is if the subtraction of these two is divisible by 11, the modular, and then we say they're congruent. So we're going to pair 10 and 1 up, because we cannot find a number that times 10 congruent to 1 modulo 11. So let's try 9. If we do 9 times 8, that's 72, and divide by 11, we won't get remainder 1. And 9 times 7, 54, it doesn't work. 9 times 6, 9 times 7, 63, doesn't work. And then 9 times 6, 54, that doesn't work. 9 times 5, 45, doesn't work. And the 3 times 6, 36, doesn't work. And the 3 times 9, 27. But keep trying these, we found out 9 times 5 will give us 45, and 45 is going to be congruent to -1. Oh, wait, hold on. sorry, it should be 9 times 6. And try it again. So 9 times 6, which is equal to 54. And 54 is congruent to -1 modulo 11. Because 54 minus -1, that's 55. 55 is divisible by 11. So we're going to pair these two up. So we're looking for the pair, two numbers. The product is divided by 11, either has a remainder 1 or -1. Okay, so we pair 9 and 6 up, and we try 8 and 7. 8 times 7, 56, and 56 is congruent to 1 modulo 11. So we're going to pair these two up. And 5 times 10 and 2, we can pair them up. Pretty much you just keep trying and until you found the product, which is congruent to -1 modulo 11. Or 4 times 3, that is going to give us 12, and congruent to 1 modulo 11. Okay, so this is how we're going to pair these numbers up. We put, so 10 factorial, we're going to pair up 10 and 1, 9 and 6, 8 and 7, and 5 times 2, 4 times 3. Now, and this will be congruent to, because 10 times 1 congruent to -1, 9 times 6 congruent to -1, and 8 times 7 congruent to +1, 5 times 2 congruent to -1, 4 times 3 congruent to +1. Okay, and we multiply these numbers together. -1 times -1 is +1. +1 times 1 still +1 times -1, that will give us -1 modulo 11. Over here, I actually used a property that we have learned before. So the property is if we have A congruent to B, say modulo 11 or any modular, C congruent to D modular 11 or anything, we will get, multiply the left sides, A times C is going to be congruent to B times D modulo 11. So that's, and I'm actually using this property because, so what I'm doing is I'm going to multiply all these left sides. So let me move this one up here. It's 10 times 1 congruent equals 10 congruent to -11 modular, -1 modular 11. So what I just did was to multiply the left sides. So you will get 10 times 1, this pair times 9 times 6, this pair right here, and 8 times 7, this pair, and 5 times 2, this pair, and 4 times 3, that pair, and multiply all the right sides. If we multiply all the right sides, you will get exactly these. And after we multiply it out, well, you get -1 and you still have modulo 11. So we're using the property written in blue right here. Okay, so now we proved 10 factorial is congruent to -1 modulo 11. So let's write down here 10 factorial is congruent to -1 modulo 11, which is explained in the previous video. This means by definition 10 factorial plus 1 is divisible by 11. So I'm going to just use the symbol here.